Hello, everybody. Thank you so much for coming this evening. My name is Jo Franchetti, and as Jonathan said, I'm a developer advocate at Ably, and I like to make wearable technology, specifically things with lots of lights on that can connect to the internet, because I like to be sparkly. And I started making wearable tech projects a couple of years ago, my first being a light-up tweet-controlled wedding dress. And when I started, I had no real clue what I was doing, and I made a few very silly mistakes around choices of hardware and how to connect everything up. And so my hope for this talk is to give you a little direction if you're looking to get into hardware, but maybe you're a bit afraid about where to start, and to get you over that initial sort of hardware is scary hurdle. So this time I wanted to make something that we could all interact with together, because I don't know about you, but I've been missing having friends and colleagues and just other humans around me. So I thought, what if we make a wearable that lets my friends change the color of what I'm wearing in real time, kind of like a multiplayer version of Microsoft Paint, but wearable. So in order to realize this dream, we're going to need a few things. First of all, we're going to need an array of lights, which we can change the color of. Second of all, we're going to need a microprocessor, which is going to control these lights. We're going to need an app where users can set the colors, and we're going to need a method of sending messages to and from the app and the microprocessor. So let's start with the array of lights first. It's going to be a 16 by 16 grid of LEDs. And the LEDs that we'll be using in this project are called addressable RGB LEDs. Addressable means that we can target each one individually, and RGB means that we can set them to basically any color we can think of, using a very similar color value to what you've probably all already seen in CSS. And the product name, if you're looking to buy these, they're called NeoPixels. And the LEDs come in these ribbon strips, which makes working with them nice and easy, as we don't have to individually solder each LED. And it also makes them nicely robust for a wearable. Because we've got the fewer solder points, it means there are fewer places where it's likely to snap. These strips are great because they have nice clear labeling, so we can see which lines carry which thing. So we've got a ground line, a data line, and a power line. And it makes it a lot easier when you're connecting them up. So to keep these strips safe in the wearable, what I did was I sewed two pieces of fabric together to make pockets for each strip. And so it would ideally look like this. It actually ended up looking like this because I can't sew very well. And once I'd inserted the strips into those pockets, they needed to be soldered together so that the power, the data, and the ground lines that I mentioned were all connected up together. And you can buy a soldering iron online for about £30. And I use single core copper wire here to connect them all up. I also recommend getting a heat-proof mat for your desk if you're going to be soldering on your desk. You can get silicone baking sheets, which are brilliant because then you can use them for cookies as well as for soldering. And there are lots of tutorial videos of soldering online, so I'm not going to go into it here. Suffice to say that it isn't too scary once you've had a few goes, and you'll get the hang of it pretty quickly. So once both ends were soldered up, this is our finished flexible LED array. And I've got a little video of it here. So you can see sort of how flexible it is, and that's really important for a wearable, that it's flexible but also quite strong. So now that we have our LED array, we need a way of controlling what colors we're going to send to it. And we use a microprocessor for this because they can do enough calculations to control the lights, but they're also nice and small and they can be easily hidden in a wearable. So the microprocessor that I chose to use is this one. It's called the Adafruit Feather Huzzah. You can see the size of it here. It's actually very small. It's 5 centimeters by 2 centimeters, and it has Wi-Fi on the board, which means that I can easily connect it to the internet. It costs about £20 to buy, which is a really great price. And it's low power, so it can take a small USB battery, something like this, which is great for a wearable because you can hide it in your pocket. It runs C and C++ out of the box, and you can write the software for it using the Arduino IDE, which you can download for free off the Arduino website. The Arduino IDE is really great because it comes with a whole load of libraries and sample code that you can use to get up and running with the board really quickly. And there's a load of really nice walkthroughs for how to get started. Yes, Arduino IDE. So the code for the Adafruit Feather Huzzah looks a little bit like this. So what I've done here is I have included the library that comes with the Arduino IDE that powers the NeoPixels. And then I've told it what pin I'm going to be sending the data out on. So you can see the pins on the board here. Then I've told it how many lights are in my array. So we've got 256. Then I'm telling it what kind of lights I have, which is the Neo RGB. This is just a thing to look out for when you're buying the strip. Make sure you know whether you've got RGB or RGBW. Strip.begin initializes the strip. It makes it possible to send colors to it, but it also sets all of the colors to black, which means off. And then what we're doing here is we're doing a loop through each of the lights, and we are using set pixel color to set the color of the lights. And this takes two values. It takes a number, which is the number of each individual pixel in the array. So those are numbered from 0 to 255. And then we're sending it a color as well. So you might recognize this from your CSS. This is white. So what we're doing is we're looping through every single light and setting the color to white. You can see here I've labeled the pins. So this is pin 4 here. We want to connect this up to our positive voltage, and ground is going to go to ground. So now we have a display and a way of controlling it, and now we need a way to tell the controller what colors to set. And being a web developer, I opted for a web app. And you can check out the code that I wrote at the link that I've put down here. Don't worry, I will share the slides and all the links out at the end of the talk so you can peruse the code at your leisure. But the app looks like this, and it has some buttons at the top where the user can pick a color. And it has a square for each pixel represented in my pixel array. So they can pick a color and then pick a pixel. Once a color and a pixel has been selected by the user, we want to not only update the square in the app, but also the square on the t-shirt. And we do that using a real-time data channel, which publishes messages that contain the color and the pixel that was chosen. And we can also subscribe to this channel to listen for changes that might be made by other people who are also using the app. So you can have a go of this app at this URL here, which I may be able to paste into the chat if I can find the chat. Or somebody else could paste into the chat for me kindly. So if you visit that, you should start to see some pixels light up. So I'm going to keep going because we only have 20 minutes, but you can keep playing with that. So on the front end of this app, we're using Ably to do our publish and subscribe to the messaging channel. And Ably comes with a JavaScript SDK to manage the publishing and subscribing for you. So here I'm making a new instance of the Ably real-time library, and then I'm connecting it to a channel called t-shirt. So here's the instancing. I'm setting the channel name as t-shirt, and then we're attaching to that channel. The cool thing is that all the other users of the web app are also subscribed to this channel. Oh, this is so nice. So everyone is getting the same update. So everyone is able to see what pixels other people are drawing. I'm using the Ably SDK create token request to authenticate and be allowed to connect to the data stream. And on the back end, our node server is going to require the Ably SDK as well to do the authentication. So we're using a token request instead of directly using the API key because it's just a little bit more secure. And you can see all of that code in the web app if you have a look on Glitch. As an aside, in fact, all of this code is also on GitHub, and I will share the link to the GitHub at the end. So now that we've established a connection to our channel, we need to publish a message to that channel when a click event happens on a square. So here I'm adding an event listener for a click on each square in that array. And when clicked, it's going to get the number of the square, which I've set as an ID. It's going to fill the color of the square with the selected color. And then it's going to do this channel.publish with the pixel value and the RGB value to send the pixel and color out to the t-shirt. So an example of the data that's being sent out might look like this. So if you clicked on square number 1 and sent a color purple, this is the data that would be sent. So we want the web app to also display the pixels which are being clicked by other users. So as well as publishing, we need to subscribe to the messages. And we can subscribe to the channel like this, channel.subscribe, and then we can process the message that we're getting back. So I've got a few different options here. So I can process the sync message and change the color of the pixels on everybody's different apps. I can also reset the display if it's getting a bit full as it currently is. I could optionally reset. Now this is all well and good, but we also need a way to get the data to the Hussar, because at the moment we're just on the web and talking about our web app. And you might be familiar already, you're probably already familiar with HTTP, which is the protocol that browsers use to request web pages. And HTTP is a protocol, which just means it's the way that two things talk to each other. And it's great, it powers websites and APIs, and it's built to be very descriptive and flexible. And it can be used for IoT connections, but it's not lightweight and it's not terribly fast. And on our low power IoT devices, we don't have very much memory, we don't have very much power, and we might not have very much bandwidth. So we need a protocol that's designed to be small and fast. And luckily, there is such a thing, and it's called Message Queuing Telemetry Transport, or MQTT, which is a connectivity protocol which was designed to be extremely lightweight. Connecting to a server takes about 80 bytes, and the device stays connected the entire time, so we don't have to keep making new connections. Data is published when it's pushed from the device, and the device subscribes to data that's coming from the server. And because the size of the data is very small, we can send messages really quickly, which makes our hardware very responsive. It makes it very feasible to change the lights on the t-shirt in real time. So MQTT is a great fit for our hardware, but we're going to need an MQTT broker. And this is the server that the devices connect to use the protocol. And it keeps track of all the clients that are connected and what they're subscribed to, and it forwards any messages to any subscribers. And in this case, I'm using mqtt.ably.io as my broker. They're a third party that your IO things can connect to send and receive messages. The cool thing about the Ably MQTT broker is the fact that because I'm already using the Ably JavaScript SDK, any messages that I've sent in my browser on any channels are also automatically sent out over MQTT, so I don't need to do any extra setup there. So now I need to code for the Feather Hussar with the Arduino IDE to start actually subscribing to channels on the board as well as in the app. So to do so, I'm using this MQTT library and this Wi-Fi client secure library. And to make my life easier, I've set up a little config object here, which makes it easier to keep track of my credentials. So I've set up my SSID and the password for that, and then the URL of my broker, the port that it'll be using, the username and password that my broker has provided me with. And then that scary looking blob of hex code is the fingerprint of the SSL certificate from mqtt.ably.io. And we need this so that this library here can verify that the SSL certificate that it sees when it opens a connection. If we don't have this fingerprint, trying to open a connection over HTTPS will fail. And then finally here we've got the channel name. So similar to what we did for the web app, we need the Feather Hussar to connect to the Ably MQTT server and then subscribe to a channel. So first we create a new instance of both the secure Wi-Fi and the MQTT clients. Once we're connected to the Wi-Fi, the secure client lets MQTT use SSL. We then connect with the credentials that we supplied in the config, and when a message is received on message, we can then process it. So we can get that first half that was the pixel number, the second half that was the color, and we can do what I showed you right at the beginning, where we send it to the pixels using set pixel color. So, demo time. I mean, I see you're all already using the app, but what I'm going to do is I'm going to stop sharing my screen and give you a bit of a better view of the t-shirt. So let's bring you in closer and see if you can actually see. Can you see any colors in there? Yeah. Oh, thank the demo gods. It actually worked. I love the heart that you've all sent me. That's very cute. Okay, I'm going to bring back. And let's see if I can share my screen again. So as I promised, this is the URL for all of the code. If you would like to build your own t-shirt, you can fork that project there and it'll set you up with all the code that you need for the Arduino IDE and to make your own version of the little glitch app that I made as well. I hope that this talk has demystified IoT and hardware a little bit for you, and that it encourages you to give hardware a try. Thank you so much for listening.
So if anyone wants to ask any questions, you can either put them in the chat or put them in the Q&A. I'll ask a question. What is the next thing after this? Last year you did your Christmas jumper, and then obviously this is the sequel. So what is the sequel to this? What is going to complete the trilogy?
So we've been working on a sequel to the Christmas jumper that has some animated GIFs in it. So I don't know if anybody saw my Christmas jumper from last Christmas. I had a similar idea to this, but it showed a different Christmas icon depending on what Christmas music was playing, and I would like it to maybe show a GIF instead. So we're going to try getting some animation on the display, which will be fun.
Have you considered going completely insane with this, but making a full t-shirt or a full jumper made of these kind of small things, and then instead of having a web app with a few squares, you would have like a 3JS kind of thing where you would be able to rotate the t-shirt and write something on your back, for example?
So, I mean, that would be completely awesome. The constraints that we have here are the power that is supplied. So with this many lights, this power supply runs out in about an hour, and this is quite a brick of a thing. So the more lights you have, the faster you burn through your power. And also, this is already quite warm. It's definitely a winter outfit. But yeah, I mean, there's nothing to stop you coating an entire suit in LEDs. Like, let's do it.
That's the next talk then.
I think Christian has an interesting question.
Are you aware of cheap? I don't actually know of boards that could take a sim, but there must be some. Does anybody else in the chat know of it? Do Raspberry Pis take a sim? I can't even remember.
I think Raspberry Pis can take a sim module, but it gets big.
Yeah. Yeah, I don't know of anything that's sort of that small that does that. if you went to EMF camp a couple of years ago, the badge for EMF camp could take us in. I'm not sure what they used for that though.
Oh, that's cool.